Now, let's take a look at this question on Kjehdahl analysis. Now, Kjehdahl analysis is used to quantify nitrogen. Dumas is also used to quantify nitrogen, but in a direct manner. So, if you will see a question on Kjehdahl analysis, you see a compound or a sample was subjected to Kjehdahl analysis. Ammonia was given off. Now, the next thing is that the ammonia that was given off was now reacted with a standard acid. The standard acid will be the one to fetch out the value of the ammonia that was given off. So the value of the sample was given because at the end of the day, we want to calculate what is the percentage of nitrogen in the soil. If this is the whole soil, so the soil sample or the organic compound is equivalent to 0.75 gram. That's the soil sample. Now, we are looking for percentage of what? Nitrogen. That's what we are looking for. So in this case, if you take a look at this question, they said ammonia was given off. Now, when ammonia is given off, so that will be our NH3. And don't forget, our nitrogen is present in this ammonia. So plus, he said ammonia given off, when they subjected this sample, the ammonia given off was neutralized. The ammonia given off was neutralized. I told you, after the ammonia have been given off, an acid, the standard acid is used to neutralize it. So the standard acid that was used is H2SO4. It will give you NH4 ammonium sulfate. Now, if you are to balance it, there will be 2 here. There must be 2 in front of that one. To balance the equation, there will be 2. So meaning you are in 2:1 to each other. Now, they gave us a value, and where's the value? They gave us the value of H2SO4. Now, the value of H2SO4 given was 10 mil in 1 molar. Now, this 10 mil in 1 molar, they said this value completely neutralized this NH3. So in this case, it means it is this exact value that reacted with NH3. In some cases, this value is in excess, but in this case, they said this value neutralized this value, meaning that the whole of this reacted with this. So I can use this value here to look for this value. It won't be wrong. So 10 mil 1 mole, I can convert it to mole. Molarity. Molarity equals to our mole over volume. So molarity equals 1 equals my mole over what's the V? V is the volume. Volume of this guy is 10 mil. 10 divided by 1000 will give me 10 divided by 1000 should give me 0.01 liter. So from here, we know that our mole, the mole of H2SO4 will be equivalent to 0.01 mole. Now, so I can come here and say the mole here is 0.01 mole for H2SO4. Then this one is X mole for ammonia. So from here we can say it's very easy. If you do this, so X will be equivalent to, that will be 2 multiplied by 0.01, which is equal to 0.02 mole. 0.02 mole of ammonia. 0.02 mole of ammonia. Now, that's so easy. So from here, since we know the mole of ammonia, we can go on. Now, why this question is very easy is because the value given to me here, that value is not in excess. That was the exact value. So from here, what do? Very simple. I can convert this mole of ammonia to mass of ammonia. So you know that mole equals what? Mass over molar mass. So from here, 0.02 mole of ammonia equals X over molar mass of ammonia. Of this ammonia should be 17. That's 17. So X equals, if we multiply that, our mole, 0.2, it should give us 0.34 gram of ammonia. Now, if I know the mass of ammonia, what else can I know? If I know the mass of ammonia, I can know, don't forget, we are looking for nitrogen. we are looking for nitrogen. So you remember that if you need mass composition, nitrogen will be the molar mass of nitrogen over the molar mass of ammonia multiplied by what's the total value of ammonia. This is the total value of ammonia, which is 0.34 gram. So from here we already know that molar mass of ammonia is 14 over molar mass of nitrogen is 14, of that of ammonia is 17, multiplied by the total ammonia is 34. So we can know the mass composition. Yes, mass composition of nitrogen. So from there, what is the mass composition of nitrogen from here? This value should give us 0.28 gram of who? Of nitrogen. So simple. We got this from ammonia. So this is that of nitrogen. So to end the calculation, the question we are looking for, what we are looking for from what I have here is percentage of nitrogen. So how do I look for percentage of nitrogen? Percentage of nitrogen is very easy. I just say you are looking for a percentage of nitrogen, you say your percentage of nitrogen. Then we now say, since the whole sample, look at the whole sample, this is the sample. So the sample is 0.75. Our nitrogen is 0. So our nitrogen over the sample times 100. Nitrogen. So what is the mass of nitrogen? 0.28 gram of nitrogen. What's the sample? What's the mass of the whole, what do you call it? Whole sample. The whole sample is 0.75. Now multiply it by 100. So do that, punch that on your calculator. 0.28 multiplied by 100. Then you divide it by 0.75. So you will get 37.3%. Very simple. Now, what's easy about this question? What's easy about this question is that the standard acid given to you. Now, this acid that is here can be HCl, but in this case it's H2SO4. So if you see a question, ammonia was given off, and the ammonia given off will be reacted with the standard acid. I think that is clear. Ammonia was given off. The ammonia given off will be reacted with the standard acid. I think that is clear. Now, in this question, the standard acid given to us was not in excess. This is simple. Let's take another type of question whereby the standard acid given to us will be in excess. Now, let's take a look at this question. This is another type of question. Yeah, Famjo will be helping you on how to go about questions like this. Now, we are applying Kjehdahl method to solve this question. This compound was subjected to Kjehdahl analysis. And I told you, anytime we subject a compound to a Kjehdahl analysis, ammonia is given off. Can you see ammonia is given off? Now, the previous questions that we solved, ammonia was also given off. So any question you see, ammonia will be given off. Now, the ammonia given off was absorbed by a standard acid. Now, 20 ml of 0.1 molar HCl solution was the standard acid that was used to absorb the ammonia. In the last question I gave you, it was H2SO4 that was used as the standard acid. Now, the difference between this question and the first question we solved is that they said, firstly, they use HCl. The other question we use, what do you call it? We use H2SO4. So, meaning here we are going to say ammonia was absorbed this time around by what? HCl, our standard acid, which is going to give us ammonium chloride. Now, if you balance it, you don't need to put 2 here. In the case of the H2SO4, we put 2 here because it will need to be balanced. Now, this is the ammonia that was given off, if you do not forget. Now, the next thing is that gave us some information about the standard acid. What was the information? The standard acid was 20 ml in 0.1 molar. Now, in the previous question, all I did is that the value given to me on H2SO4 was converted to mole, and I used that value to get this value. But I can't do that now. Why? Because this value was not the exact value that neutralized this NH3. This value is in excess. How do I know? Because if you read the question forward, the question says the excess of acid, meaning when NH3 plus HCl reacts, they said, and evolved ammonia was absorbed in 20 ml of HCl. Meaning when ammonia that was evolved reacted with HCl, the excess of the acid, that means this guy and this excess HCl will form ammonium chloride plus imaginary, let's say imaginary, yes, imaginary excess or extra HCl. That means in this case, NH3 plus HCl will not only give us NH4Cl, it should also be NH4Cl plus an imaginary that we know that is there, plus excess of what? HCl. That means HCl will completely neutralize NH3 and some part of it is still remaining. This was different from the first one. In the first case, in the first question, the H2SO4 completely neutralized the ammonia without remaining anything. In this case, the HCl neutralized the ammonia and some part of the HCl was still remaining. So if that is the case, it means I can't use this value to get this value. I can't turn this to mole, and if I use this value like this to get this value of ammonia will be wrong because this value is in excess. So I need to know what is the exact amount of HCl that now react. Is it 20 mil, 0.1 mil molar? Was this the exact amount that reacts with NH3? No, because this value is in excess. Now, the only thing we can now do, they now further the question. They said the excess of acid, they are talking about this excess. The excess of acid required 15 mil of 0.1 molar NaOH. So what we'll do is that, very simple, original value, or you say initial value of HCl that we use, or we say the original value of HCl or the initial value of HCl. The initial value of HCl is going to be 20 mil 0.1 molar, of which you can convert it to what? To mole. To mole to be mole equals, since you know that molarity equals mole over volume, so I can just say very simple, mole will now be equals to 0.1 molar multiplied by this 20 will be divided by 1000. That's 0.02 dm cube. So what will then be our new mole like that will then be what? 0.1 multiplied by our 0.02. Then we now have 0.002 mole of HCl. Now this mole is the initial value of HCl. Now we will now look for the excess of acid. That means there was an excess here. Don't forget, what I need is that I need the exact amount. This mole here, this value here was not the exact amount. This value here was the whole acid that was used against NH3 that was in excess. So I want to know, after this guy reacted with this guy, there was an excess remaining. If I know this excess and I know the original, if you take away the original from the excess, we will know the exact that reacted with ammonia. So let's go and look for the excess. To get the excess, they now gave us, they said the excess of the acid require 15 mil of our, so we say NaOH, a base, was reacted with this excess plus HCl, the HCl that was in excess, the HCl that was in excess, it will give us, if you balance that, NaCl plus H2O. So from here, we know that NaOH was given to be, our NaOH was given to be, 15 mil 0.1 molar. With this information, I can convert this, because this is going to be 1:1. I can convert this statement to because molarity equals mole over volume. So our molarity is 0.1 equals x mole over the volume here is 15, that will be 0.015. I think we are following. 0.015. So we need to get the mole, out of that. So 0.015 multiplied by what 0.1. That will give us the mole of this NaOH is now 0.00015 mole. I got that using this information. So against X mole, since they are 1:1, it will mean that HCl, the excess HCl that remain after this guy and this guy reacted, this excess will be equivalent to 0.0015 mole. Now let's go back. This is the original, this is the excess, this is what remain, this is this, and this is what remain after it reacted. So I can now say initial acid minus the excess, that will now be what? 0.002 minus 0.0015. Is everybody still following? 0.002 minus 0.0015. That will give us what? 0.005 mole of what? The mole of what, everybody? The mole of HCl that reacted with ammonia. Now see the stress this question gave us. The stress this question gave us is that this value is in excess. I can't use, you can say that this value gave me 0.002 mole. I can't use this 0.002 mole to look for ammonia because this value is in excess. So what we did was that they told us that after this guy reacted with this guy, it formed NH4Cl plus some excess. They now said this excess, the excess was now reacted with what? With sodium hydroxide. So the excess HCl with sodium hydroxide. I get it. So the sodium hydroxide is 0.015 mole. You know the way I got that. So with the excess, so I got the excess. Now, original amount that reacted, the original amount that absorbed ammonia, this is it. Then the excess that remain after absorbing ammonia, this is it. So if you minus these two from each other, it will give you the exact amount of what? HCl that reacted with ammonia. Now, I think you can further the question from here. You should be able to complete the question from here because I'm going to flip now, because we've now agreed that HCl reacted with what? Ammonia, that gave us ammonium chloride. We've been able to note that the exact value of this guy that reacted, the exact value, this is the exact value here, which is going to be what? 0.00, can you see this value? 0.005 mole of HCl was the exact value that reacted with ammonia. So you know that they are both in 1:1, meaning that our ammonia will also be equivalent to what? 0.0005 mole. Now from this stage, the next thing to do now is to convert. You know what to do next, because what we'll be doing now is we are looking for nitrogen in ammonia. Do you remember? So from here I can convert the mole of ammonia, which is mole equals mass over molar mass, abi, that's 0.0005 equals x over molar mass of ammonia is 17. So x equals 0.0005 times 17. That will now give us what? 0.0085. 85 what? Gram of ammonia. From here, I can look for nitrogen. Don't forget that we are looking for percentage. So I can look for nitrogen. This is for ammonia. So I can now say to look for mass composition of nitrogen will be molar mass of nitrogen over molar mass of ammonia multiplied by the total. What's the total mass of ammonia? 0.0085 gram. So that would be 14 over 17 multiplied by 0.0085 gram. So from here we can say 14 multiplied by 0.0085, which is going to be divided by our 17. That will give us 0.007 of nitrogen. So from the question, we have to look for what is the percentage of nitrogen in the compound. So what is the mass? What is the mass of the organic compound? This is it, which is the same thing as what? 0. So we can now say percentage of nitrogen will be the mass of nitrogen over mass of compound times 100. Is that okay? So what is the mass of nitrogen? The mass of nitrogen here is the mass of nitrogen. Okay, we've gotten the mass of nitrogen here to be 0.007 over mass of the compound. Where's the compound? This is 0.0295. 0.0295. Can you see? Gram. So everything multiplied by 100. So 0.007 times 100. That's 0.7. Then everything divided by 0.0295, which is going to give us what? 23.7. Now, if you do this multiplied by 100, you should have 23.7% of nitrogen. So, what is the essence? What is the things you need to pay attention to if you have to solve question on Kjehdahl analysis? Number one, your compound, they'll give you the sample. They'll give you the value of the sample. Then it was subjected to Kjehdahl analysis. Now, ammonia was given off. Is that okay? The ammonia given off, they can give you the value straightforward, which is rare. They can't just give you the ammonia. So the ammonia given off was reacted with what? Our standard acid. Our standard acid might be in excess or might not be in excess. In the first example, the standard acid completely neutralized the ammonia without being in excess. That one was straightforward, meaning that the value of the acid given to you, you can use that value to get your ammonia straightforward. But in the second case, the standard acid, which was HCl, they said it was in excess. So meaning that value given to me on HCl, I can't use it directly to get my ammonia. So you saw what I did there. So those are the two things you should pay attention to. Our acid here was in excess. In the first question, the acid was not in excess. So those are the things. So, and the goal is that you need ammonia. You need the exact and correct amount of ammonia. Once you get the correct amount of ammonia, from ammonia you get your nitrogen. Then from nitrogen, you can do percentage of nitrogen in the organic sample. I think that is clear. So I'll drop a question. You're also going to try to question yourself before your test or your exam.